Thanks. Yeah, my name is Brian Bear. I work for Index AR Solutions and Newport News Shipbuilding. And how all that works is about 4 years ago or so, Newport News Shipbuilding started looking into AR, started implementing it, researching it, developing it. And last January, Index AR Solutions started as an independent company, and we formed a teaming agreement with Newport News Shipbuilding. So we're able to leverage all the project work, all the development work that's being done at Newport News Shipbuilding, as well as the some 7,600 engineers and designers that we have there. So that's how things got started. Probably one of our most robust use cases that we have is inspection and planning in AR. I'm going to show a video that shows that. So I'll cue that up. And there's no After Effects in the video. This is all the stuff that we've done. The first thing you'll see is a kind of a prototype that we use to test some of the room visualization. The rest of them is solutions to requests for issues and problems that they had in the shipyard that we solved with AR. So. Is there audio?
Today we demonstrated the capabilities of augmented reality to digitally overlay stud locations onto a steel panel. In the current process, they're able to etch the locations of the studs into the panel, but not onto the stiffener. And using an iPad and a movable target, we're able to overlay multiple stud locations on the panel. So it's extremely accurate on the locations on the panel and the stiffeners. It's able to produce pretty much any information you might need.
Well, today what we did is that we used the augmented reality to perform an inspection by bringing the product model into the space. This is a technology we've never been able to do anything like this before, short of just using tape measures.
Today we were going on the ship and actually doing a survey for some temporary structure for lifting pads that were left on the ship. What we were using is an augmented reality program today in which we had a model of all of the lifting pad structure along with the hull structure of the ship. Very useful to see what was there, what wasn't there, and you could actually see what was left. Locating the structure was definitely easy. I actually came up with some structure that I didn't know was there that I'm going to have to go back and do a little bit of research on.
Augmented reality has been an important tool used in pipe fitting. We were using it for planning, but using the augmented reality, we could actually see the changes overlaid on the actual physical aspects of the ship. And we were very pleased. I was skeptical about it being useful, but that opinion has changed.
My mechanics, they love it. They said it's excellent. It's the best tool we ever had for us, like the information.
Man, it was great. I mean, it has an overlay of the job. It gives us a three-dimensional view of what we're looking at, as opposed to the 2D views on the drawing when you flip it back and forth.
No flipping through, flip. You just hit the button. It's pretty much the information was there.
It's a good deal. It eliminates a lot of hassle and saves a lot of time also.
So the testimonies there at the end, those were all, those were end users of the product. And the last one in particular, or second to last one, Harvey Ellis, he just was honored with the 40-year Master Shipbuilder Award. So it's really neat to see how they don't have to be 18 years old to use the AR, to use an iPad. And they've embraced it, and Randy Hill there, his particular problem was we couldn't show it because we're on aircraft carriers and submarines, so there's only so much that we can show. But he had a long run of pipe that he had to take down and reinstall multiple times because there was equipment in there. It was a tight space, and they had to move the equipment around. So they just couldn't plan for that. They couldn't visualize what was going on. So we were able to bring the product model into the space, overlay proposed changes in the product model, being able to interact with those systems, turn those on and off. And the systems are from anything from ventilation to piping to equipment pool paths, whatever they needed. And so they're able to turn those on and off. So that's about it. If you're interested in learning more, we'd love to talk to you, especially if you want to learn how to integrate these AR engineering services into your business. So, thanks.
Awesome. Great. Thank you. So it definitely looks like you have some questions. We'll start here.
What technology were you using for your tracking?
We're using the Vuforia SDK, and then we're building on top of that. So we're really developing our own toolkit to be able to do some different things with how do you move a target around in a space, how do you feed that back to the user, some proprietary ways of where you don't have to have knowledge of the target when you author the AR. So starting with Vuforia and then kind of building on top of that.
Did you have to put in markers in the physical environment?
Yeah, so we've done a lot of work with that. So depending on the situation, it could be a two-dimensional marker, it could be a three-dimensional marker. And then again, just some neat way, we had one compartment that's 120 feet long, and the ability to use one image target in that compartment was part of the success of that project. Yep.
Actually, a very related question. If I saw that correctly, that cube with the hexagon structure was your marker in some of the cases, right?
That is correct, yeah.
So then how do you calibrate, or how do you align that marker with your model? Like, I'm assuming the end user can put that marker in the environment?
That's
right. So then how do you tell the end user where that goes? Did you specify in the model that?
So we actually did it where the end user tells us where it goes in the app itself. So I can't get into how we did that. That's part of some of the stuff that we're building into the toolkit, I think. But we allowed the user to put that marker in the environment and then take some measurements and feed that into the app, and then be able to use an overhead map and show them where they are and which way they're looking at the cube and things like that.
Right, thanks.
So.
And then it looks like we have one question back over here.
Actually, I have a lot of questions, so I think I'm just going to come up to you and talk to you. But just for the people out here, how did you digitize? I mean, how did you scan all the, what did you use to scan everything?
We're using the 3D product model that was used to design and construct the aircraft carrier there. So in that case, it's CATIA. And we have the advantage of the modelers that are creating in that software, as well as there's some Autodesk products as well in some of the different examples that you saw. But there's definitely a workflow of how you get that from that model into AR.
So all these models are just theoretical models? Or?
No, they're actually the product model they use to design the ship with.
Okay, so any other questions than the several that guy has? Okay, we have one over here.
Is this ready for variable conditions, or is this like fixed spots and fixed places? And also, how are you handling the lighting variations that would definitely crop up?
We've done some different things with the illumination of, whether it's by the user or other methods. And your first question was? It is, you can move it around. That's right.
Okay, great. So big round of applause for Brian and the rest of our speakers.